So I'm going to share my screen here. Don't know where everyone's at. It's on the calendar. I sent out a reminder last night, but we will get started here. Oh, come on, menu bar. Okay. So what we're going to do today is we're going to be previewing vocabulary for Module 3, right? I know a lot of us are still in Module 2, but Module 3 is coming, right? And it's probably the most important module that we do this year, aside from genetics, which is pretty important as well. But the first two are really introduction modules, right? What is science? Heat transfer should have been kind of a review from 6th grade. And then, of course, every time I do a virtual session, my dog thinks it's like playtime. Don't really get that, but Kendrick, relax. Okay. So we're going to preview some of this vocabulary so that we're kind of already thinking about it when we go into the lessons. And we're going to talk about study skills, how to remember this vocabulary, and then we're going to watch a short video on plate tectonics, which is one of the main topics in the next module. And there's an exit ticket going on as well. So the warm-up was supposed to be this Poll Everywhere website, which I will send it in the chat to you, Riley. Oh, yay! Giovanni's here too. Okay, so where's the chat at? Chat. Okay, so if you go to this link, it's going to take you to 3 poll questions, right? And on my end, I can actually see when you guys respond. But the first question is, send in at least 2 vocabulary words from science. This is just like a vague one because it's going to make this really cool assembly of words. So in the chat, there is no worries about being late. In the chat, there's this link. So click on the link and it should take you to a page where you're going to be able to send in your own answers. Right? You can also text and do it from your phone, but that requires like a little bit of setting up. So take a second now to click on this from the chat or type it in yourself, and you are going to send in at least 2 vocabulary words. So I'm also going to do this so I can show you guys how it looks. Uh-oh, this isn't the right one. Maybe I can't have all my questions published at once. All right, I'm still learning how to use this thing. All right, don't go to that link yet. I want you to do this one first. So I guess I will unpublish. Let's see if that worked. Nope, that's good. All right, so we'll get to this. We'll do this one first then, and then we'll see if the other questions appear. But basically, I'm asking you, what do you already know about plate tectonics and the layers of the Earth? So in your response box, once you go there, it's too early for you. It is early. You could type, I don't know what that is, right? Or you could say something like, I know the Earth has layers, right? So whatever you know already, and it can be that you don't know very much, which is fine. So take a couple of seconds, go to the link, and type out something. If you know about plate tectonics, if you know about the layers of the Earth. Part of the reason I'm doing this too is if you know a lot already, then I might be able to skip you through some of these lessons and activities so you don't have to spend your time on them. See, and then I get little I get little speech bubbles that appear of what people said, but it doesn't say your name. So no one's going to know you said it, except we know I said those things because you just saw me type them. So go to the link and type something that you know about plate tectonics, about the layers of the earth, about anything that you know about this topic. And I'm going to give you guys 2 minutes while I refill my coffee, and then I want to see more bubbles here. And I know it's early, but get your brain turned on. Think about what you know about plate tectonics and the layers of the earth. Okay, awesome. Someone else, I know what you said, that there's layers of the earth. Let's see if we can get one more response as I play with my dog here. Oh, dogs are lots of work, guys. Think before you get a dog. Oh, what is the link? It's this one right here, polev.com/Jamie Dinsmoo, not my whole name, 438. We're gonna try to do some more of these little poll things because they're more interactive. And I wish I could have showed you the other one because it makes this cool like word bubble that looks really cool, but we'll probably get back to it eventually. All right, I'm gonna leave that there. We're gonna come back to this. I'm gonna leave this poll open so that people who watch the video can also participate, right? So if you're watching this video after the virtual session, you can still go to this website and participate in the poll. All right, otherwise, if you're typing something, keep going, but I'm gonna move on here. Excuse me. So this is all the new vocab for Module 3. At first I thought, oh, this is a lot, but then I realized it's really not too much, right? It could be a lot worse. So it's basically different kinds of volcanoes, the different layers of the earth, and then a few other words. So this may seem kind of strange, but we're just gonna read through them together. And by that, I mean, I'll read them to you because I want you to hear the words and I want you to start thinking about them before you do the lessons. So, asthenosphere is the layer of the Earth's mantle that is liquid and in constant motion. This motion causes the movement of the plates. Okay, we don't really know too much about that yet, but we'll come back to that. A cinder volcano is a sudden violent eruption that forms a volcano of ash and cinders. So a sudden eruption, there's ash. Cinders are kind of like burnt up little pieces of rock or wood. A composite volcano is a volcano formed from multiple eruptions, right? So there's layers of ash, there's layers of lava. Continental crust is the rocky material that makes up the continents. Okay, we're probably familiar with that one. Continental drift, the theory that the Earth's continents were once part of one landmass that broke up and drifted apart. Have you guys heard about that theory before? Continental drift? The large landmass was called Pangaea, right? Which is kind of a weird word. I'll even type it here in the chat so you can see how it's spelled. Pangaea, right? That all the continents were one thing, then they broke off and separated. So next one, this is a review word. This one's from Module 2, so a lot of people should be familiar with this one. Convection the transfer of heat in a liquid or a gas, the warmer gas rises and the cooler gas or liquid falls, resulting in a current. Convection is really key for this topic because convection in the mantle is what's causing the plates to move on the surface of the Earth. The core of the Earth, right, is the innermost portion. It's divided into a solid inner core and a liquid outer core. So in this module, you guys are actually going to be building or drawing a model of the Earth, right? And I know one student already told me that they want to make a cake, which is great. Hopefully they bring it tomorrow so we can eat it, but we'll be eating the layers of the Earth. Epicenter is the point on the Earth's surface that lies directly above the place deep in the Earth that an earthquake occurred, right? So it's basically the beginning or the center of an earthquake. And yes, like a pot of boiling water is an awesome description of convection, right? The water is constantly moving and churning with currents. Lithosphere is the outermost layer of the Earth, which is rocky and solid. Magma is the molten rock that makes up the Earth's mantle. Oceanic crust is the crust that lies beneath the ocean. I like that one because it sounds like common sense. Seismic waves are waves of energy passing through the Earth that are caused by an earthquake. So when an earthquake happens, waves actually move, right? And I know several people who have been in earthquakes and been near the epicenter of an earthquake, they describe that you can see the wave. The wave moves things up and down as it's traveling, right? Which is really scary. And then another type of volcano, a shield volcano, a volcano formed from slow, gentle eruptions, which causes a buildup of layers of lava, right? That would be like one of those volcanoes in Hawaii. It's just constantly oozing lava, right? But it's not like erupting like crazy. It's just like oozing lava for years. So again, knowing all of the different types of volcanoes is probably not the priority here, but knowing the layers of the Earth and understanding how they cause the plates to move is going to be a big deal in this module. So here's a picture actually from one of the lessons. Usually I use Google Images, but I figured, all right, no, I'll use the lessons this time. Right, we see convection going on here, and we see some of the layers of the Earth. We have the crust, which is the most outside. We have the mantle, which is the gooey lava part. We have the outer core and the inner core, right? And the inner core is the only part really that's solid, and the crust. Like the crust of the Earth is pretty solid. But these gases are constantly warming and cooling, and they cause a current. And not just one, they cause many currents all throughout the Earth. Right, so I said which process is going on here. Well, I kind of told you, but which process is going on here? Anybody have an idea? You can type it in the chat box. You can speak if you would like. As if the gases are warming and then cooling and causing a current, what is going on there? Which heat transfer is that we learned about, or that I just mentioned? And that, yes, thank you, convection. I was gonna say that Giovanni just said was like a pot of boiling water, right? Convection is going on here. So plate tectonics, we're gonna watch this little video. And like I said, this is a pretty short virtual session. It's early for me too, sorry guys. I have a very complicated schedule, which requires me to be up way too early constantly. So plate tectonics, it's a theory explaining the structure of the Earth's crust and many associated phenomena, right? They mean volcanoes, earthquakes, as resulting from the interaction of rigid lithospheric plates that move slowly over the underlying mantle, right? It's kind of a long definition, but really, the Earth has plates on it, right? If you think about let's think about a pool, right? We have a swimming pool and you have a bunch of floats. You have all those loungy floats, right, that people can lay on. And if no one's in the pool and you're all just standing around looking at the pool, the floats are moving, right? Not crazy, but they're moving around a little bit. They don't stay in one spot. That's kind of how the Earth's plates are. They're moving around on this liquid mantle of the Earth, right? And it's not a crazy movement usually, it's just a little bit. Every once in a while, those pool floats might hit each other, right? Or they might both go in the same direction. So that's the kind of stuff that's happening with the Earth's plates, is that sometimes they hit each other, sometimes they move away from each other, right? And that can cause all types of things. They can cause mountains to form, can cause earthquakes, volcanoes, and it can even cause pieces of continent to break off and move away. So there's a lot going on. And the reason that this is a theory and not a law is because it's happening really slowly, right? It's a slow process. And in this video, this person gives a little bit more background. Kendrick, what are you chewing on? 1 second. Okay. Good, he's chewing on his toy. Thought maybe it was my shoe. Okay, so this video kind of explains a little bit more about the process and gives a few more vocabulary words, right? The ones that we just previewed here, these are the basics. So there are more vocab that you may see in this module, and that when you learn about this stuff again, because if you haven't noticed, science kind of cycles back, right? You go back to learning about stuff you already learned about and you learn deeper. So we're gonna watch this video, which I guess I closed out of. We might have to watch an ad, that sucks.
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s.
So he just said, this guy talks a little too fast for my personal taste. You've never had anything chew your shoes where your cat likes to play with the lace. Yeah. Well, that's kind of what he likes plastic. So he thinks the ends of the laces, he likes to chew that, and any plasticky part. So what this guy just said really quickly here was 200 years ago about somebody came up with this theory, right? A scientist was like, you know what, I think the plates move. And most scientists were like, no. And then in the 60s, right, which is really recent, your parents might even have been alive, possibly. I don't know, my parents were, right? Pretty recently, scientists were like, actually, yeah, this does sound like something that makes sense. So we're gonna find out why.
When mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified
right, so we can actually use satellites to track the plates moving now. So we have more advanced technology, which allows us to really see the movement, right? Before we had satellites and all that kind of stuff, it was kind of hard to say if plates were moving, right? Imagine how you would measure that. Like, even if you went outside and measured, you know, how close the ocean was to you or something, that's not going to really tell you if the plates are moving, right? So before satellites, we really couldn't measure that.
Explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. and some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental land masses, the thinner of the two plates bends and slides under the other. As the edge of the seafloor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls, and the crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days, we directly track that motion.
Okay.
It's with another ocean plate, it bends and slides under the other.
So what you're
As the
talking
edge of
about here is that this was another reason that scientists kind of didn't believe this, right? Was because they were like, all right, if the plates are moving on the mantle, let's say we agree, how come this plate is moving faster than the mantle, right? They were like, that doesn't make sense. What's going on? And then, you know, some scientists went off on a crazy thing, probably said something about aliens or something, right? But then the rest of them were like, wait, this plate's going underneath, right? It's being pulled into the Earth's mantle. And like he showed with the jewelry thing, right? If you've ever had this happen to you where you have a chain, right? It starts to pull itself and go faster and faster and faster. So scientists have observed that happening with the plates. And if you're thinking, all right, well, who really cares about this, right? When these plates hit each other or move apart from each other, that's when we get earthquakes and volcanoes. And that kind of stuff can really destroy entire cities, right?
Dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster the remaining plate behind it moves. You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them. Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually, those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
All right, so that was just a little bit more about like how plate tectonics works, and I like the visuals provided there. And then, of course, we could spend a lot of time talking about the consequences of earthquakes and volcanoes and all that, but I think we kind of have our own personal ideas. Have you guys ever been in an earthquake? Let me get the chat box over here again, if I can. Okay, Marie says no, nope. Yeah, me either. I think there was, when I lived in Texas, there was like a small one, but no one, some people claimed they felt it, but I don't think anyone really felt it, right? But then a lot of people I know who've lived on the West Coast, especially for a long time, have been through at least one really bad earthquake. And then I'm gonna guess that you've never been through a volcanic eruption, right? But have you guys ever seen a volcano? Have you ever been to like Hawaii or somewhere where you see a volcano happening? No. Yeah, me either, actually. I've never seen a volcano in person. So, you know, that's something to think about. I've seen videos and all of that, but this is one of those things where until it really happens to you, you don't realize how bad it can be, right? So regardless, we're studying what causes these things to happen in this module. So the exit here, actually, before we get to the exit, I just want to say, how do you guys think, what's the best way to study, right? We have all this new vocab. Some of it, it's not all going to be in the first lesson, right? We're going to have it broken up over 5 or 6 lessons here. What do you think the best way is to remember this vocabulary? Can't get to the chat. There we go. Write it all down. Okay, yeah. Well, that seems really obvious, but that's true. So definitely having it written down is one thing. But what's another way that you can actually learn the vocab, right? Because I'm going to tell you, I don't think I've ever learned cinder volcano and composite volcano, right? I've never like talked about those. I don't even really think they're that important, right? But for this module, they might ask you a question like, oh, what kind of volcano is this? So maybe I need to know it. So what's another way? Maybe take notes, make it shorter. Ooh, I like that one. So putting this in your own words, right? So continental crust, you could just write rocky crust, right? You might know in your mind, continent, continental, same thing. Convection, right? You might have your own way of saying that. So that's definitely one way. Shorten it, right? Put in your own words. There's no reason to write the entire definition if you don't need to. And then take notes, right? So the biggest thing, guys, is using the vocab in context, right? Or actually using the vocab. So if you can talk about the vocab to your friend, to your parents, you can write with the vocab, right? That means that you understand it and you know what it means. Copy and paste it, yes, but you want to make sure that you yourself are remembering it, right? And part of the great thing about writing it down is that it does help you remember. If you guys would like, I can share, do you guys want me to share this document with you so you can have this vocab? Okay, so I'm gonna share this with you so that you can copy and paste it. If you would like, you can look at it, you can copy it into your notes, right? Whatever your style is. Okay, so there's the Google Doc that you can open and have for yourself. But I personally, oh, and you know what else is very good to know? I got this vocab actually from the glossary, which I don't know if you guys have seen, which for this class, it actually is pretty good. For some of the other classes, it's terrible. But basically, I just went to any lesson in Module 3, geologic processes, and I went to, as Canvas takes 10 years to load, I went to glossary. Right now, the problem is it shows all the vocab for the whole semester. Right? Like you see words in here like absorption, allele, amplitude. Some of those are words we've already learned. Some of them we haven't learned. But this is a helpful page to look at, right? You could print this so you have it. You could even tape it into your notebook. You could highlight on it. I pulled out all the words that have to do with this topic specifically in the Google Doc. But this is a helpful thing to reference occasionally, especially if you want to look up what a definition is for something. So keep in mind, you can always print this out and have that for your own personal use. Okay, so good. So like I said, using the vocab is super important. Right? And I really try to push my students in science to talk with science vocab, because sometimes we know what things are and we can explain them, but we're not using the vocab. So what I'm going to do to start this process for you guys is I'm going to ask you to send me an email with 2 new vocabulary words used in a sentence. So you can pick any of the 2 words that you see on the list, and I want you to use them in a sentence that makes sense, right? So it could be something about the definition. You might Google cinder volcano and see where one is, and you might say like the volcano located in blah, blah, blah is a cinder volcano, something like that, right? So just using the vocabulary so that there's a way for you to kind of remember it and get it embedded in your head. And then the second question here is about plate tectonics. So describing it in your own words, and then thinking about why it's important for us to study it, and then which associated phenomena do they cause, right? I gave you some hints about the earthquakes and the volcanoes being some of those things. And then you may, come here. You may want to look that up, right? That video that we watched is there's a million of them on YouTube. Most of them are pretty good. Some of them are long, so I would probably not watch like a 20-minute one. But they can show you the plates interacting, right? And you can get a better idea. So you guys now have the Google Doc, right? But these are the 2 questions that I would like for you to send me an email with an answer. Yeah, you can watch a 20-minute one if you have time. In fact, I found one about Mount St. Helens erupting. Hendrik, stop. Right, which is in Oregon. And I was like, ooh, yay, but it was 20 minutes long and it was really boring. So I didn't show you guys that one. So, use your own judgment. If you start watching it and you're like, this is terrible, then pick something else. But I personally like to watch videos when I learn about stuff because I like to see what's going on and hear about it at the same time. Okay, so this is going to be due, I guess I'll write that here. This is going to be due by Friday at midnight, right? Which gives you today to work on this and tomorrow. Should not take you too long. In fact, you probably will spend about 15 minutes, I would say, on this. And then the other thing that I have to remind you of before we go is tomorrow we're doing a lab in the middle school lab time. And my dog is trying to eat plants. It's like never ending. All right. And in this lab, what we're going to do is we're going to have a competition where we're going to try to build the best solar water heaters, which I realize it's not super sunny anymore. So we may have to wait until it's sunny to measure them. But basically, I have foil, cardboard, a bunch of materials, and you and a partner or you by yourself are going to build a solar water heater, and whoever's heats water up the most is going to get a prize. So it should be fun. If you don't want to participate in it, that's fine. You don't have to. You can just say, no thanks. But it should be good. It's going to be a contest. It's going to be from 9:30 to 11:30. But if you come a little later, that's fine. You can start at like 10:30. You don't have to start right at 9:30. It'll probably take you like 30 minutes to build it, I would say. So as long as you get there by 11, you could do it. And then I will make a really quick little virtual video about it, like what materials we're using, what's going on. So if you want to sort of check in from home, that's fine. And I might even have people from home vote on which one looks the best until we can test them with the sun. And it might even be sunny tomorrow though, right? Maybe. It was sunny yesterday and it was supposed to rain, so you never know. All right, so by Friday at midnight, you're answering these 2 questions using the 2 vocab words in a sentence and describing plate tectonics. This is only going to help you as you move into Module 3 with all of the content. All right, do you guys have any other questions? Okay, well, in that case, we're going to end this virtual session. Thank you guys for attending. Actually, let me write down who's here really quickly before you leave. Okay, Lonnie, Marie, Alexia, and Riley. Okay, awesome. So please email me your answer to the questions. Yep, you send an email because Canvas doesn't let me add new assignments. It's the worst. So you're just going to send me an email, and I'm going to be keeping track of who does these things. And at the end of the semester, I'm going to be adding points to your grade. Or taking points away from your grade if you don't do anything. So keep that in mind. Otherwise, I'm going to end the meeting. And thank you guys for coming. And I know it's early. Maybe next virtual session, I'll try to make it a little later. Like maybe we could start at 9:30. If that would be better for you guys. All right, well, I will talk to you soon. Bye. Still early.